Dear students, welcome to the problem solving session on Fourier transforms. In this session, we are going to see some interesting problems also which are very important for exam point of view. Find the Fourier transform for a given function f of x is equal to a minus mod x for mod x less than a. That means x lies between minus a to a. We know that the mod x function 0 a minus a. If I say mod x less than a, then it lies between minus a to a, and hence we have to deduce this. We always solve the problem step by step. My first step is finding Fourier transform. This is the crucial and important and mandatory steps. Then next step is going to be either inverse Fourier transform or Parseval's identity. It is according to the question. Now in our question we have two deductions. So one is going to be done by inverse Fourier transform. The second is achieved by Parseval's identity. So we are going to use all the three. So let us go into the solution. First write the Fourier transform formulae. My f of x is going to be a minus mod x at the interval minus a comma plus a. So I can write like this. But it is very tough to integrate this function. So we recall formula e power in theta is equal to cos n theta plus I sin n theta. Here we have e power isx. So cos sx plus I sin sx. I am going to replace e power isx by this. And we know the property for the function minus a to a f of x dx. It will become 0 when it is odd. It will become 2 times 0 to a f of x dx when the function f of x is even. Now we know the constant function is even. Mod x is also even. Therefore a minus mod x is also an even function. A minus mod x into cos sx even into even, that is also an even function. And next a minus mod x into sine, this is odd. So even into odd is going to be odd function. Whenever we know the function is odd at the interval minus a to a, this is going to be 0. So I can retain only this minus a to a minus mod x cos sx dx. Now we can see that a minus mod x into cos sx is an even function. So I can write this as 2 times 1 by square root of 2 pi 0 to a minus mod x cos sx dx. Now we know the property of mod x. It will behave x at the positive side, that is x greater than 0. Since my limit is positive, it starts from 0 and move to plus a. So I can write this mod x simply as x. Now simplifying this, that 2 and root 2 will get cancelled. I'll be getting square root of 2 by pi. Remaining things are same. Now we have to apply Bernoulli's formula. Integral u dv is equal to uv minus u dash v1 etc. Take the non-diminishing term as dv, that is cos sx dx. U as a minus x. My u dash and take is going to be minus 1 u double dash is 0. Integrating dv, I'll be getting sin sx by s. Integrating v, again I'll get minus cos sx by s square. Now as usual, mapping this and substituting the limit, we'll be getting the answer. Now we can see the upper limit a. When I put a here, a minus a is 0. When I put the lower limit, then sin 0 is 0. Both the cases, this is going to be 0. Now, when I substitute the upper and lower limit, taking this minus outside, I'll be having minus square root of 2 by pi cos as minus 1 by s square. If I multiply the minus inside, I'll be getting 1 minus cos as by s square. But I want to prove integral 0 to infinity sin t by t whole square dt and power 4. But my answer is something 1 minus cos. Now it is not possible. So we just recall our basic formula. 1 minus cos theta is 2 sin square theta by 2. Therefore, 1 minus cos as is 2 sin square as by 2. If I substitute this and simplifying, I'll be getting my final answer. Since we have square here and here also we have s square, I can write like this. And it is easy to see it is an even function because of this square. Now step 1 gets over. It's time to find the deduction. go for step 2. Write the inverse Fourier transform formulae. Just now we found capital F of S. Substitute in the formulae. Now I want to prove 0 to infinity sin t by t whole square dt is equal to pi by 2. See this problem. Whatever the things it is unwanted, I have to eliminate this. E power minus isx. If I put x equal to 0, then this e power is0 will become 1. Good. Next, a is unwanted. If I put a equal to 2, then as by 2 will become s. Again, if I put s equal to t and ds equal to dt, then my problem will be converted into this format. Now I can cancel this root 2 and I'm multiplying root pi by root pi. I'll be getting 2 by pi minus infinity to infinity. This simply will become sin t by t whole square dt. And my left hand side will become f of 0 when I substitute x equal to 0. So I'm just showing the typed version. Now my problem f of x is going to be a minus mod x, and we know that my a is 2. When I substitute x equal to 0, f of 0 is going to be 2 minus 0. It is simply 2. I can substitute the value. Next, we can see this function with whole square is an even function. Therefore, again I can apply the property. I can write this as 2 into 2 by pi 0 to infinity sin t by t whole square dt. Now this 2 get cancelled. I can bring this 2 by pi to the other side and we will achieve the deduction. So the first deduction gets over. Now we are going for the second deduction. Parseval's identity can be used. Just substitute the values of capital F of S and small f of x. Simplifying this, we will be getting 2 square is 4, root 2 is 2 and root pi square is pi. Minus infinity to infinity, I can write the remaining things. Here whole square again square. So I can write it as power 4 ds. Right hand side remains as it is. Now as usual we have to remove the unwanted terms. 0 to infinity sin t by t whole power 4 dt. So we have to adjust the problem accordingly. So put a equal to 2 will change as by 2 as simply s. Then if I put s equal to t and ds equal to dt, my problem will be almost changed to this format. On the right hand side, this minus a will become minus 2 and plus a will become plus 2. You can see the version. Now I can see this sin t by t whole power 4 in the left hand side. 2 minus mod x whole square in the right hand side. Both are even function. So using the property, I can write it as 2 times 8 by pi 0 to infinity. On the right hand side, 2 times 0 to 2. Now this 2 get cancelled and now bring this 8 by pi to the other side. So it will become pi by 8 integral 0 to 2. First expand this, then it is easy for us to integrate this. X square minus 4x plus 4. Integrating this, we'll be getting x cube by 3 minus 4x square by 2, that is minus 2x square plus 4x. When I put my lower limit, everything is 0. When I put my upper limit, pi by 8, here we will be having 8 by 3 minus 8 plus 8. So both will get cancelled. I'll be getting the answer pi by 3. So we achieved the second deduction also. Hence, we complete this problem. Now, in exams, instead of a minus mod x, many times they will ask 1 minus mod x. Now, students will be getting happy by seeing this 1 minus mod x. They always think that 1 minus mod x is very easy compared to a minus mod x. Both are easy, but you should be very careful when you solve the problem. So, I'm going to show where is the change in the problem. Instead of a minus mod x, if you have 1 minus mod x. As usual, the same thing, find the Fourier transform. Here up to Fourier transform, it is going to be the same. Instead of a, you have 1. You'll be getting the same. You can pause it, you can write and you can do the practice. Now, when I apply inverse, I don't have a here because here you have 1. If it is a, I can just put a equal to 2 and I will tally. But now there is no a, but there is some s by 2. But I want to achieve like sin t by t whole square dt. But I have s by 2. So I have to convert this s by 2 into t. So simply I can say this as s equal to 2t. So if you put s equal to 2t, 2 will get cancelled, s will become t. Hope you understand. So put s equal to 2t, then ds will become 2 into dt, and also I see that e power minus isx is there. So put x equal to 0, then e power 0 will become 1. So now everything is ready. I can cancel this root 2, and I can multiply this root by root pi. I'll be writing 1, I'll be writing 2 by pi minus infinity to infinity. When I substitute all these things, I'll be getting sine t. Here s equal to 2t. So I'll be getting 2t whole square 2 into dt. You can see the typed version. Now two things I have to do. I have to cancel this 2 and 2 with this 2 because we have whole square, and I have to find the value of f of 0. My f of x is 1 minus mod x. My f of 0 is simply 1. If I substitute both, I'll be getting 1 equal to 1 by pi minus infinity to infinity sine t by t whole square dt. So understand student, the change is here s equal to 2t. When we have a minus mod x problem, we put a equal to t, then it will make as by 2s s. So remember this carefully. Next, the sine t by t whole square is again an even function. So using the property, I can write this as 2 times 1 by pi 0 to infinity sine t by t whole square dt. Now taking this 2 by pi to the other side, I will achieve the deduction. Same thing for Parseval's identity. Substitute capital F of s and f of x values, and now as usual simplify this. 2 square is 4. Here 2 divided by pi minus infinity to infinity sine s by 2 divided by s whole square is whole power 4 ds. I can write like this. Now as usual, to find the identity sine t by t whole power 4 dt, I want to make some adjustment. I'll put s equal to 2t or s by 2 is equal to t. Both are same. Then ds will become 2 into dt. Substituting this, we'll be getting 8 by pi minus infinity to infinity sine t by 2t whole power 4 2 into dt. 1 by 2 power 4 is going to be 16. Therefore, this 8 and 2 will get cancelled with this 2 power 4. And also we can see this is whole power 4 and this is whole square. Both are even function. I can write this as 2 times 0 to infinity here and 2 times 0 to 1 because of the property. Now I can cancel this 2 and 2 and move the 1 by pi to the other side. I'll be getting like this. Next step, we have to integrate this. Before integrating this, expand this and then integrate this. Substituting the lower limit, it is 0. Substituting the upper limit, both will get cancelled. We'll be getting pi by 3 as my final deduction. So in this session, we deal very important problems, that is a minus mod x and 1 minus mod x. In the deduction part, we put that a equal to 2 here. Here we don't have a, so I am putting s equal to 2t, ds equal to 2 into dt. In this case, we did s equal to t, ds equal to simply dt. Hope you understand, students.
Thanks for watching. Subscribe to our channel and share to your friends. See you in the next video. Bye bye.